Radioactivity. Henry Becquerel discovered the phenomenon of radioactivity in 1896. From the experiments, it was concluded that uranium and its salts by themselves spontaneously emit some kind of radiations which can pass through paper, glass, etc., and they affect the photographic plate. These radiations were called the Becquerel rays. The process of spontaneous emission of radiation is called radioactivity. The substances which have the property of spontaneous emission of radiation are called radioactive substances. Later on, Madame Curie and her husband Pierre Curie found that an ore of uranium is much more radioactive than pure uranium. Those which pass undeviated or uncharged or neutral radiations and are called gamma particles. Elements of atomic number higher than 82 exhibit the phenomenon of radioactivity. These are called the neutral radioactive substances. Classification of radiations from a radioactive substance. A small quantity of radioactive material in a deep cavity of a thick block of lead. When a strong magnetic field is applied at right angles to their path, the beam split into three distinct components. Those which turn to the left are positively charged and are called the alpha particles. Those which turn to the right are negatively charged and are called the beta particles. Those which pass undeviated or uncharged or neutral radiations and are called gamma particles. Similarly, when an electric field is applied, those which turn towards the negative plate are the positively charged alpha particles. Those which turn towards the positive plate are the negatively charged beta particles. Those which pass undeviated are the uncharged gamma particles. Beta particles deviated more than the alpha particles. Properties of alpha, beta and gamma radiations. Properties of alpha particles. An alpha particle consists of 2 protons and 2 neutrons. It is the same as doubly ionized helium atom, that is, a helium nucleus containing 2 protons and 2 neutrons. It is represented as 4/2 helium or helium++. The mass of an alpha particle is 4 times the mass of a proton, and its charge is twice the charge of proton. The speed of alpha particles is of the order of 10 to the power of 7 per second. The speed of all alpha particles need not be same even though the source is same. On account of their large kinetic energy, alpha particles produce instant ionization of the gases through which they pass. They have small penetrating power when compared to beta particles and gamma radiations. They are deflected by electric and magnetic fields. The deflection of alpha particles is less as compared to that of beta particles because alpha particles are heavier. Alpha particles affect photographic plate and cause fluorescence on striking a fluorescent material. Alpha particles destroy the living cells and cause biological damage. Alpha particles get scattered while passing through the thin mica or gold foils. The energy of an alpha particle is absorbed rapidly as it moves through a medium, and therefore its penetrating power is quite small. Properties of beta particles. Beta particles are the fast moving electrons emitted from the nucleus of the atom. The mass and charge of a beta particle are same as those of an electron. The speed of the beta particle is of the order of 10 to the power of 8 m s to the power of -1, but less than the speed of the light. The speeds of all beta particles emitted from a radioactive nucleus are need not be same. They are deflected by electric and magnetic fields. The deflection of beta particles is opposite to that of alpha particles and is large since these particles are lighter. Beta particles affect photographic plates and cause scintillations on a fluorescent material. The penetrating power of beta particles is more than that of alpha particles but less than that of gamma rays. Beta particles can cause radiation damage. Therefore, the radioactive source should be kept in a lead container. Properties of gamma rays. Gamma rays are electromagnetic radiations. The wavelength of gamma rays are shorter than those of X-rays. The gamma rays, being electromagnetic radiations, travel with the speed of light. The ionizing power of gamma radiations is very low compared to that of alpha and beta particles. The penetrating power of gamma rays is more than that of alpha and beta particles. Gamma rays are unaffected by electric and magnetic fields. Gamma rays can easily pass through the human body and destroy human cells. Hence, in treatment of cancer, gamma rays are used to kill cancer cells.